Okay, so today we're going to talk about radian measure. All right, so let's take a look at this. Hopefully you remember a little bit of circles from last year in geometry. All right, so we have this circle here, and notice I have this angle, and it is centered at 0. So the vertex is at the center of the circle. So hopefully remember that this is called a central angle. And hopefully you remember that central angles are equal to its intercepted arc. So it's intercepted arc. So if you draw your angle here out to the edge of the circle, so its intercepted arc is the arc that's between the two sides of your rays of the angle. So if the arc is equal to 50 degrees, then the angle, this angle here, is equal to 50 degrees. Okay? So let's talk about what a radian is. A radian is the measure of a central angle whose intercepted arc is equal to the length of the radius. Okay, so now I'm talking about the length of the radius, okay? The length of the arc, the length of the radius. So when I talk about the length of the arc, this here, I'm not talking about degrees. I'm talking about if you actually took the edge of a circle or the edge of a piece of a circle and actually could pull it straight and measure it on a ruler. That's what I'm talking about. All right, so let's take a look at the first example of circle O. And what I have here, the arc, the intercepted arc here is equal to R. And the length of the radius is also equal to R. So if I want to know what the measure of this angle is, angle AOB, in radians. So a radian, remember, a radian is when the intercepted arc is equal to the length of the radius. So the arc is equal to the radius. Therefore, angle AOB is equal to 1 radian. Remember, a radian is when the length of the arc is equal to the length of the radius. All right, let's take a look at 2. The length of the arc is equal to 2, and the length of the radius is also equal to 2. So what I want to know, what is the measure of my angle in radians? So you might be quick to think, oh yeah, it's 2 radians. It's not 2 radians. Since the arc is equal to the radius, remember what a radian is, that is 1 radian. All right, let's take a look at the bottom ones down here. I'm just going to move everything up a tiny bit. Okay, so let's take a look at circle number 3, circle O. So notice that my arc is length 3, but my radius has a length, of 1. All right, so they're not equal. So I would want to make them equal because remember, a radian is when the arc is equal to the radius. So what I could do is take the arc and break it up into groups of 3. So if I break this up, this would be a length of 1. I could break this piece up so it's 1, 1, right? So if I have this arc here is 1, this arc here is 1, this arc is a length of 1, and this arc has a length of 1, then the whole arc has a length of 3, right? So 1, 2, 3 here. Now this arc is equal to this, that's a radian. This arc is equal to the radius, that's another radian, and this arc is equal to this radius, that's another radian. So angle AOB, this angle, the whole angle, is equal to 3 radians. All right, let's take a look at the last one. So my arc has a length of 8. My radius has a length of 2. They are not equal. Remember, a radian is when the arc is equal to the radius. So I could break up 8 into groups of length 2. So this would have a length of 2. This would have a length of 2. And this would have a length of 2 and 2. So now I have this arc is 2. This arc is 2, that's a total of 4 here. This arc is 2, that's a total of 6. And this arc is 2, that's a total of 8. So now I have my arc is equal to my radius. And I have 1, 2, 3, 4 of them. So angle AOB, this whole angle, is equal to 4 radians. So hopefully you realize now that all I have to really do is take the arc and divide by the radius. And that will give me the angle in radians. All right, so let's write that down. So the measure of the angle in radians is equal to the intercepted arc divided by the radius. Okay, so instead of writing that whole thing out, since I'm talking about my angle, and our angle is theta, so we would say theta is equal to S over R. So theta is your angle in radians. S would be your arc, and R would be your radius. Okay, so let's take a look at how to change from degrees to radians. So flip it over on the back. All right, so changing from degrees to radians. So the first thing you need to know is what is the circumference of a circle. So hopefully you remember the circumference of a circle formula is C is equal to, C for circumference, 2 pi r. Now remember, circumference of a circle is the distance, so if you have a circle here, it's the distance going around the circle. Okay, it's the length of the edge of the circle. So I'm going to let S, so I'm over here now, let S, remember what is S? S is your arc. Okay, what's the arc of my circle? Right, the whole circle, the arc of my whole circle would be my circumference. So that's going to equal my circumference. And what does my circumference equal? Circumference is equal to 2 pi r. All right, now, another thing you need to know, since I'm talking about the whole circumference of a circle, well, what would be my theta for a whole circle? What would be my angle for a whole circle? The angle for a whole circle, theta, would be equal to 360 degrees. Okay, so remember that formula you just wrote down to find an angle in, to find the angle in radians? You would do theta, your angle in radians, is equal to S over R, right? Your intercepted arc divided by your radius. All right, now I'm just going to do a substitution. What is my S? So looking up here, S is my circumference, which is 2 pi r. So I'm just doing a substitution. S is 2 pi r over R. So what I could do is cross off the r's. They reduce to 1 and 1. So I'm left with 2 pi. Therefore, theta is equal to 2 pi. But we know what theta is. Theta, which is a whole circle, right, is 360 degrees. So by substitution, theta is 360 degrees is equal to 2 pi. So if I now divide everything by 2, I get theta is equal to 180 degrees. So that you have to know. You need to know 2 pi is equal to 360 and pi is equal to 180 degrees. So therefore, to figure out the measure of an angle in radians, you would do the measure in degrees over the measure in radians, and that's equal to 180 over pi. And then when we actually do problems like this, it really just comes out to being, to change from degrees to radians, you just put it with pi over 180 because of the cross multiplication. And when I cross multiply and, right, if I'm looking for my angle in radians, if this is my x, I'm looking for the angle in radians, I cross multiply, I get my degrees times pi equals 180 times x, and then I divide both sides by 180. So you can see it's my degrees times pi divided by 180 degrees, and that will give me my angle in radians. Okay? So let's take a look at the first example. I want to change 80 degrees to radian measure. So I put it with pi over 180, and then I reduce it. So it's 80 pi divided by 180. So what I do now is I reduce, so plug in your calculator, 80 divided by 180, reduce the fraction, you get 4/9. So this is 4 pi over 9. That's my angle in radians. This is radian measure. So it's 4 pi over 9 radians. All right, let's do negative 135 degrees. So I take a negative 135. I put it with pi over 180. And now I'm going to plug in negative 135 divided by 180. Reduce it in your calculator. And you get negative 3/4. So it's negative 3/4 pi, and this is radians. All right, so now we also have to be able to go back the other way. If I give you radians, I have to be able to go back to degrees. All right, so remember, what did I say about pi? Well, pi, remember, is equal to 180 degrees. We just did it above. So all I have to do, since pi is equal to 180 degrees, all I have to do is change pi to 180. So I have, what is pi over 3? So remember, this is radians. So now if I want to change this to degrees, I change pi to 180. So it's 180 over 3, which is 60 degrees. This would be 3 pi over 4 radians. So I change my pi to 180 degrees, so it's 3 times 180 over 4, which comes out to be 135 degrees. Okay, so that's it for radian measure. We'll practice more in class, and I'll see you guys tomorrow. Have a good night. Okay, so let's take a look at the other examples. It says, in a circle, the length of a radius is 4 centimeters. Find the length of an arc intercepted by a central angle whose measure is 1.5 radians. All right, so this is what it's saying. You have a circle, and it has a radius of 4 centimeters. And it says, find the length of an arc intersected by a central angle. So now I have the central angle. Remember, central angles are formed with 2 radii. So here's my central angle, and that central angle is 1.5 radians. And I'm looking for the measure of the arc, the length of this arc here. All right, so anytime it's dealing with radius, arc, and central angle, you're going to think of that formula, theta equals S over R. Sometimes people use the formula S equals theta R. It's the same thing. It just comes from taking this formula here and cross multiplying. So either one is the same thing. I always use theta equals S over R. All right, so remember, your theta must be the angle in radians. If the angle is not in radians, it must be in, if it's in degrees, you have to put it over into radians. S is your arc, and R is your radius. All right, so now you're just going to plug everything in. My angle is in radians, so it's 1.5, equals S, which is the arc, X over the radius, which is 4. So I'll cross multiply, and we get X is equal to 6. All right, let's take a look at the next one. Okay, so coterminal angles in radians. So we did coterminal before. Remember, coterminal means it's an angle that shares the same terminal side of a given angle that's in standard position. So remember, those are multiples of 360 degrees. Okay, so now remember from before, 360 degrees is 2 pi because we are going to stay in radians. So if I have this angle, 2 pi over 3, I want to find a positive coterminal angle, a positive Coterminal would be to add 2 pi. So I'm going to take 2 pi over 3 and add 2 pi. So you don't want to change this over to degrees. You need to keep it in radians. So you're going to take the 2/3 and add it to 2. So in your calculator, do 2/3 plus 2. Change it over to a fraction. You get 8/3. So it would be 8 pi over 3. All right, to get a negative, you subtract multiples of 360. So negative, you would subtract 2 pi, 360, until you get a negative. So it's going to be 2 pi over 3 minus 2 pi. So in your calculator, you're going to do 2/3 minus 2, and you get negative 4/3, which is going to be negative 4 pi over 3. Okay, let's take a look at the next one. Okay, so complementary and supplementary angles in radians. So remember, complementary angles are 2 angles that add to 90, and supplementary are 2 angles that add to be 180 degrees. So remember, 2 pi is equal to 360. So pi, so this is from before, pi is equal to 180 degrees. So what would 90 degrees be? Well, it's half of 180. So pi over 2, so it's half of pi, is 90 degrees. All right, so to get your complement, remember, to get your complement, you do 90 degrees minus your angle. So it's going to be 90 degrees, which is pi over 2, minus your angle, which is pi over 3 for the first one. All right, so you're going to plug this in your calculator. So that's 1/2 minus 1/3 in your calculator, and you get 1/6, which is going to be 1 pi over 6. All right, supplement. All right, so remember, the supplement is 180 minus your angle. So 180, remember, is pi minus pi over 3. So you're going to do 1 minus 1/3. So 1 minus 1/3 is 2/3. So this is going to be 2 pi over 3. Okay, so that's it, and we'll practice in class tomorrow. Have a good night.